Let me see. Okay. Rate of reaction. Oh, it's long. It's long. Yeah, see whether I have another image for that. Okay. The formula itself is like this, yeah. This K here. Oh, is going to be long.
Okay.
EART. Your job is to find EA. Is that what your teacher said?
Yeah. He said try to find the activation energy.
Okay, good. Okay, good. Wow. Then how to get K? Because you buy the light stick, right?
Mm-hmm.
You buy the light stick. Yeah. Okay. Okay. This one, okay. EA is activation energy, yeah, which you must find later. T is temperature. T is temperature. R is gas constant. You know the gas constant, right?
8.31.
31. Okay. This E, you know, right?
The
E from mathematics. The
like really long number.
Yeah. 2.7, blah, 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 blah. This one, A, this activation energy, you calculate later. This one, you calculate later. Then this rate constant from experiment. Yeah, from experiment. Then the experiment, let me think. Yeah. Oh, I know. Oh, I remember I give you that your teacher say have a sensor, right, to measure the brightness. I even send you the apps to measure the brightness. Like that. Okay. So we are going to use that. Yeah. Okay. Good. Okay. Okay. You know what is this K here? SL rate constant. You learn how to get the rate constant.
I think not in class because it was HL, but I think we went through it before.
Oh, okay. The rate constant, because this one, the rate is equals to K.
Oh, then the order of reaction.
Yeah. PQ. Yeah. This A and B are the concentration of reactants. But we have a problem because you cannot control the concentration of the reactants, because when you buy, the reactants is already put there. Yeah. So you cannot change it. So we use this other formula. K is equals to ln 2 over half-life. Okay.
Wait, how is the time it takes for it to like run out, is it?
No. The time it takes for it to reduce the amount by half. Yeah. So we try to get this graph here. Usually it's concentration, but for this case you adjust. Yeah. Concentration. Then this is time. Then the concentration is this much, yeah. Then the concentration of the reactant will decrease, right? Yes. So for example, concentration is let's say 10 here. Then the half-life, how do you get half-life? You draw 5, yeah. Then draw dotted lines here. T half. Yeah. Then the half-life is this much. For example, this thing is, this thing is 50 seconds. Yeah. Then this is the half here. Okay. Then you try another one here, 2.5. Then dotted lines here. So this is from point A to point B, right? A to B, then you can find T half. Then B to C is T half also, so it's 100 seconds. So it's another T half. Yeah, Ken. So from here you get that your half-life, T half is the half-life. Then ln 2 divided by that number, you get K. And this K, so don't use this method, then this K you sub in here. And you do that for one temperature. That means you do this experiment in one temperature. You understand?
Oh yeah. I think also like when I was discussing with my teacher, he said that I need to figure out a way to make the temperature remain constant. Like how do I control the temperature?
Oh,
I think he said
yeah.
to increase or decrease the temperature, I can use either the ice bath or the Bunsen burner, something like that.
Yeah.
But he just asked me how to make it constant.
How to make it constant? Very simple. Very simple. This is, let's say this is the, what do you call it, light stick here. Light stick, then the light stick is immersed here in water, like this. Yeah. You can, if you use ice bath here, can. Ice bath, can. You put ice there, or you heat it up in a Bunsen burner, can, right? So Bunsen burner is for, let's say 30 or 35, 40 and so on, right? And ice is, you need it to maintain at 20, 30 and so on, yeah? Then if you want to make it more stable, what must you do? The beaker you use bigger.
Bigger beaker.
Bigger beaker, and you have more water. So that when you just put the ice, then the temperature does not change suddenly. It will change very, very slowly. Yes, Ken?
Okay.
Better still, what they mean by water bath is double here. That means you have water, you have beaker under another bigger beaker. But this is quite troublesome. It's quite tough. Because you know why? You use the water to heat up the beaker inside. That means it's going to be very, very slow. That means you can maintain the temperature. You can maintain the temperature of the of this thing. Yeah. Yeah, then you put the Bunsen burner outside here on the, you heat up the bigger beaker to, but it's going to be slow. Yeah. I think you just use a bigger beaker so that it won't the temperature won't change so much. Then you your phone here, your phone or your sensor is here. Then you measure the brightness. This thing also, the concentration you cannot tell. So don't use concentration. The brightness here from the sensor. Yeah. So the brightness you draw here. You will get same result. Yeah. Okay. That means later you make a table here, temperature. Wow, this table is the last table. After you do so many calculations, this is the last table that you're going to get. Let's say it's 10 degrees, 15, 20, 25, 30, 35, 40. 40 is already difficult. Yeah. Then you calculate the K here. Yeah. The temperature in degrees Celsius, then you convert to Kelvin. Yeah. How many Kelvin, and so on. Yeah. Then after you get this, then we apply to this formula. How do we apply? Okay. Then this is the last table, the last table before you have a lot of data to make this table. Okay. How do you do this? You're going to plot. I forget how to do this. Oh, try do the working here. K is equals to AE minus EA over RT. You learn. Try do. Can make ln K as a subject. Yeah. Make ln K as a subject. Try write down.
We make the activation energy, is it?
No, ln K as a subject. Then you simplify.
Make ln K the subject.
Yeah. Then you simplify there. The Arrhenius equation I put to your WhatsApp. Yeah. No. Okay. I tell you how to do this. Very simple. Yeah. Ln K is equals to ln all these things, right? AE power minus EA over RT. Yeah. Which is equals to, this is multiply, right? Multiply if you do ln. Okay. You can break up, become plus, remember? Yeah. And this is ln A. Ln with E is disappear, right? Minus 1 over RT EA. Like this, yeah. Then this one, you're going to get a line here. Y is equals to M X. No. Sorry. Minus EA over R 1 over T, like this, yeah. This is M X plus C, yeah. Get, yeah. Okay, can. So you make the graph ln K against 1 over T. Okay. Then this is the, you're going to have a straight line. The gradient will be negative because minus EA over R, yeah. So C will be equals to, then you have a lot of data, right? You have data, then you draw this graph here. Then as usual, then you do the linear regression. So C is equals to ln A. So later you can calculate A equals to E power C. Yeah. Then what else? M is equals to minus EA over R. Correct? So EA will be equals to negative MR. And R, you know how much is it? 8.2. Let us, yeah. Then from here, you can get your EA. Yes, can. So I recap here. You do the experiment using this water bath. Then when you do this experiment, your job is to find these points here, yeah, the data here, yeah, so that you can later you can sketch graph to it. After you sketch graph, you get your half-life. You get your half-life, and then you get your K. That is 1K here. Yeah, 1K. So this is how. So minimum, you do the experiment how many times? Minimum 7, but might be more now, because each experiment you need to redo twice, 2 or 3 times. Correct? Yeah, you need to do 2 or 3 times, so that yeah, and each time it will take a long time because the light stick. Oh, this is the thing here. This is the problem. The light stick, you buy one, it may last you something like 1 or 2 hours, can be more, can be 5-6 hours. Correct. That means for you to wait until half is going to be long. Correct. Yes.
Yeah.
Let me think. So that's one of the problem. You discuss with your teacher, yeah.
Okay.
You discuss with your teacher, but my idea is if it takes too long for you, then you don't need to wait until half. Then we do some mathematical calculation. Let's say you haven't even reached B here. You just collect the data. Then we do mathematical manipulation to calculate the half-life. Yeah, Ken? Yeah, we do the calculate the half-life. Yes. Yeah, this is what you do. This is what you do first. Yeah. Okay. The school they start with any chapter?
No, after exams, it's just marking days now.
Oh, okay. You want to learn the organic chemistry? You haven't learned organic, right?
No,
School
but
haven't learned?
we learned a bit in secondary 4.
Okay. Oh, I forget. I thought we already learned. Okay, but school haven't learned organic at all.
No, for this year haven't.
For this year haven't, right? Okay, we do a quick revision on on organic chemistry. Okay. Yeah. Let me check here. Okay. Wait.